And let's go. Okay, so you have registered for and are attending Every Rock Has a Story, inspiring the next generation of geoscientists through the stories of the Earth. And this webinar, your presenters are Ethan Baxter, Jean Oviet, and Ruffman, and also Mary O'Brien. And this webinar is presented by the K-12 Working Group of the AGU Education Section. If you're not familiar with the K-12 Education Working Group, we are a subsection of the education section of AGU. Diana Ibarra and myself, Missy Holzer, we work to, as a working group, we provide a voice for the K-12 community within the education section. We share timely K-12 related opportunities and resources within the section, with section members, and we also implement methods to serve the needs of the community, which may include programming, resource curation, community building, and webinars like the one you're attending this evening. So let's switch over to tonight's event. And so we are joined by Ethan Baxter, who's a professor of Earth and Environmental Sciences and Associate Dean of STEM Disciplines at Boston College, Jean Oviet Rothman, who is a STEM education consultant, and Mary O'Brien, who's a grades 2-6 STEAM teacher at Henderson Inclusion Upper School in the Boston Public School System. Thank you and welcome to our presenters, and we're going to switch over and hear from them.
All right, very good. Thanks for the introduction. And I will start my slides in just 1 second. All right, how does that look, everybody? All right, thank you very much. Well, it is wonderful to be with you all tonight. I hope we get a few more people to join. And it's great to be with you virtually. This is how we meet these days on Zoom. And I'm glad to see we've got folks from all over the country and in fact all over the world joining us in our group tonight so far. We're going to tell you about a project that I started about 5 years ago called Every Rock Has a Story. Again, my name's Ethan Baxter. I am at Boston College. I want to just give a quick shout out now to my partners in crime, Jean Oviet Rothman, who's been working with this project on me from the beginning, and a new friend, Mary O'Brien. Jean and Mary will be sharing their perspectives on how to bring this educational resource into your classroom or learning environment as we get into the presentation. I'll start by just saying a bit more about myself. I'm a believer that when it comes to education, everybody's perspective is a valuable perspective, and everybody's background is a valuable background. So I share this so you know the background and perspective that I bring to the story and the stories that I'll be sharing. First of all, I grew up around here. I'm in Boston still, which is where I grew up. I love home. I still have rocks that I collected in my neighborhood as a child. They're in my office. I could show you if we had more time. I have an undergraduate degree in geology, a PhD in geochemistry. I did a postdoc at Caltech after that, before I started my first faculty job right back here in Boston at Boston University. And then I moved to Boston College, where I've been for the last 10 years. And my main area of research is geochemistry. In addition to my academic day job, I've derived a lot of joy over the last 10 plus years giving presentations about my science in a number of different venues. I've had the opportunity to give over 100 different invited lectures around the world at various academic institutions, and I've given live presentations to, I've counted literally over 10,000 K through 12 students over the last 10 plus years. So overall, who I am is a teacher. I'm a mentor, I'm a researcher, and as I hope to give you an example tonight, I'm a storyteller about the Earth. So I want to start by presenting some of the problems that we are trying to address with this project called Every Rock Has a Story. And the first of these, I think, is nicely summed up in this quote from a recent paper by Rachel Bernard, who is pictured here, and her colleague Emily Cooperdock, that basically says that the geosciences remain the least diverse of all the STEM fields. That's despite recognition and work over past decades to try to broaden the literal face of geosciences. This is one of the issues that I think continues to plague the geosciences, and one of the things that we'd like to address. Another quote, which is a fun one to read, but it has a very serious point. If you remember the popular TV show, The Big Bang Theory, that gentleman there was the goofy, slow-talking geologist that was constantly being made fun of by the real scientist, Sheldon, the physicist. This quote says, this is Sheldon speaking, "Do you remember how you explained to me that the Kardashians aren't real celebrities? Well, says Sheldon, geology is the Kardashians of science." Which is to say, in a lot of people's minds and popular culture in this country, geology isn't real science. In fact, if we identify a child as science-minded or gifted in science, we might want to have them push beyond or past the geosciences and get into biology, chemistry, and physics. This messaging, which may or may not be familiar to some of you, is something that we encounter a lot, where students skip geology, are steered away from geology, or their parents, teachers, or communities have a sense that it's not real, important, valuable science. And that's a real challenge because we need geoscience. Many of the great challenges that are pressing issues that face society today require fundamental geoscience research being conducted by geoscience researchers. These are issues relating to climate, environment, natural resources, water resources, our thirst for energy, and the continued risks of natural hazards. And this last bit of data down here, and there are other pieces of data like this, recent work by the National Research Council and then the Next Generation Science Standards really recommended boosting up Earth and space science content in our K through 12 curriculum. The NGSS is rich with Earth and space science content, and yet only 8 states still require a class that includes ESS content nationwide. So we're still behind in terms of taking the recommendations and bringing that recommendations into reality, into especially our K through 12 learning environments. So the overall goals for the project I'm going to jump into are twofold: to help the geosciences by inspiring all of our kids across the country and around the world, to get those kids interested in the geosciences and to make them feel like geoscience is for them. It's for everybody. And the second big goal is to strengthen this image of the geoscience by inspiring wonder, curiosity, interest, and value in the geosciences among those young kids and their parents and teachers. We want everybody to see that geoscience is real science. It's exciting, it's important, and it's relevant today. So that brings us to Every Rock Has a Story. So this is a project near and dear to my heart. As I mentioned, when I was a child, I was one of those kids that collected rocks from the very beginning. And I got excited at first, looking at the rocks and the shiny ones and the red ones and the blue ones and the round ones, and identifying them and giving them a name. In fact, a lot of the geology curriculum that I remember as a child focused on identification. The whole goal was you do the scratch test and all that stuff, and you give something a name. And the problem with that is in a lot of times that's where the exercise would end, as if there was nothing more to be said about those rocks and minerals and themes once you've identified something. And I think the most important thing that I try to reach with my audiences and with us here today is to understand that rocks and minerals are so much more than just giving them a label. We need to get away from the mundane labels and start with the stories behind them. I found that by sharing stories about those rocks, a rock is a great hook. Many, many kids will get excited about that rock, and we want to show them why they matter by telling stories that get them excited and inspired. And I, as Jean knows, because I've worked with Jean for many, many years in some of the school systems she's worked in, if I could do it, my preference would be to be live in every K through 6 classroom around the country every year and do a live presentation. I'd much rather be doing things hands-on in person than over video. Of course, that's not possible. And so that led us to Every Rock Has a Story. In fact, this started during 2020, during the COVID lockdown. I had planned to give many days worth of live classroom presentations, ranging from kindergarten to sixth grade, as I've been doing for many years. And those got canceled during COVID. And so I went home and decided that what I was going to do about it was start making YouTube videos. I'd never made a YouTube video in my life, but I made the first 44 episodes at home during a lockdown with nothing but my laptop and a bunch of rocks. Some of the nice things about the YouTube platform is it's free. Anybody with an internet connection can get on YouTube and check these out. So there's no firewall, no payment required. It's also important to me that no one's making money off this. Believe me, if I wanted to make money, this is not what I'd be doing. It's not monetized. There's no profit. So we're only doing this to get out the word about geosciences to the kids out there. YouTube also has closed captioning and translation options that make it a little bit more accessible, and that comes in handy. And as I said, that target audience is nominally an elementary school K-5 audience, but I found students and those interested in geosciences of all ages can enjoy these and find a lot of fun with them. That first season, that first 44 episodes, they were all between 5 and 10 minutes long. Each one starts with a rock, and then much more importantly is the story that comes from that rock, stories which cover almost all the geosciences. And I would say that season 1 in all of its amateurish glory is still probably the best place for the youngest learners, that K1-2 audience. I still think that season 1 is the best. This is one of the samples from season 1. This is a rock which may or may not look familiar to you. And what I want to do is just spend about 5 minutes and play just a few excerpts from one of those very, very early episodes from season 1. This is episode number 6, just to give you a sense of what those early episodes looked like. And maybe we can learn something about this particular climate rock as well. So let's just spend a few minutes watching this very early episode.
Hello everybody, welcome to Every Rock Has a Story. I've got a great story for you today. The rock of the day is one of the bigger ones that I have on the back of the table. It's this one right here. So let's hold this up. This is the rock of the day, and it is quite white, very white in color, sort of medium heavy. Let me bring it closer so you can take a look at it and maybe draw a picture for your science journal. I hope you're making a science journal with some of these videos. There's the rock, very white. It's kind of got some dents and bumps in it. And it's also, it's very smooth and round, but it's sort of powdery. It's sort of powdery coming off in my hands. White, powdery. Wait a second. I have an idea about this rock. I think I have a guess what this might be. Just wait 1 second. I have a guess. I think I know what this rock is. I think this rock is chalk. This rock is chalk. That rhymes. What if I told you that this chalk rock is half gas? What if I told you that this rock is loaded with gas inside? Would you believe me? Well, if I were you, I'd be a little suspicious. So, to test my idea that there's gas in this rock, I'd like to do a chemistry experiment with you. So, I need to take off this blanket because I am starting to warm up now that I've had that on for a while. I'm going to come a little closer. I've got this little bottle of acid, and if I'm right, if I put some acid on this rock, I can release the gas that's inside. So let's watch and listen, see if we can hear and see what happens when I put this acid on the rock. Did you see that? Did you see that? It bubbled and fizzed and gas came out of the rock. It's true. You see, CO2 is a gas that goes into the atmosphere, into the air in the sky, and CO2 is like a blanket on the earth, kind of like the blanket I was wearing to stay warm. That's what CO2 does. When you put CO2 in the atmosphere, it keeps the earth nice and warm. Not enough CO2, and you can get cold. The earth gets cold, but just enough CO2 and it's nice and warm how we like it. Sometimes, like in the Cretaceous, there's even more CO2 in the atmosphere, and it's like more blankets on the earth. So in the Cretaceous, there was lots of CO2 gas in the air in the sky, and it got really warm. So what led to this record of those hot times of the Cretaceous? Well, all that CO2 in the air also got into the ocean. This rock forms in the ocean, and you won't believe how this rock forms.
So that was an example from a very, very early episode of Every Rock Has a Story. Of course, I didn't have all of it, but the story of that rock is a story of climate. That rock holds the literal lever arms to Earth's climate, the air conditioning that's been operating for billions of years very successfully. And it's told in a way that I know a lot of students can enjoy. That first season, which went off without any planning on my part, I think was really appreciated by teachers, parents, kids. I got a lot of really positive feedback. This is a quote from a superintendent that I know who really was happy with the content. The most important responses I got were from the kids themselves. That's what this is all about. This is about bringing inspiration to kids. And I want to show you a few short videos from 3 of those kids to give you a sense of what Every Rock Has a Story did for them, what they took away from it. So these are a few quick videos that I think will give you a sense of why I decided to keep doing this.
Remember what I told you about whenever you see something in a box?
It's special?
Yeah, that's special.
What's it called?
That's a diamond. That is a real diamond. That's why it was in this box.
What's in that box?
Oh my goodness, that box has the most special rock of all. I got a note from Nora last year when she started watching the first set of episodes. And here's a copy of that note right here. It's handwritten. I'm going to read part of it to you. Nora wrote, "Hi, Ethan. I love learning about rocks. They are starting to feel magical to me." Well, that's what it's all about.
And then let me show you a little bit of what Nashea did.
Remember what I told you about whenever you see something
my name is
in a
Nashea,
box?
and today I would like to talk about my favorite rock called malachite. And the reason why is mostly because of its distinct color.
I'm going to show you guys something else that Nashea did. Last year, she watched all 44 of the original episodes, and she made this science notebook. What you can see inside, she drew the picture of every rock and did some research and wrote some extra information about every episode of Every Rock Has a Story. In fact, this page is about malachite from episode 26. I wonder if you want to make your own science notebook. If you want some suggestions for how to make a science notebook page, you can find some information in the text right below this YouTube page.
And Daniel, one of the youngest viewers, watched the entire season 1, and sent me this spectacular video that I'll play here.
I am Daniel. I am a 4-year-old geologist. I live in North Carolina. Welcome to Every Rock Has a Story.
So that's why I do this, is hearing from kids ranging in ages from 4 to 12, who I think really got something out of Every Rock Has a Story.
I am Daniel.
There we go. This is what I wanted to show you right here. There's Daniel on his first day of kindergarten, and his little board says he's 5 years old and he wants to be a geologist when he grows up. Favorite activity is doing geology. Now, not every kid's going to come away with that sensation, but it did for them. So coming out of that first season, I really felt like this was a valuable resource, educational resource, and I wanted to do something more. And the first thing I realized was that one of those goals was to help all children understand that they could be scientists, to see themselves as scientists. And one of the first things we realized was that that first season, and all of its stuck at home in COVID glory, the only geoscientist that was depicted was me. And that's great, but not if we want to reach all of our kids nationwide. And so the first thing I did when we came out of the shroud of COVID was recruit co-hosts. So starting with episode 49, all the episodes include somebody else, somebody with another identity as a geoscientist, because we want every child in our country to see themselves as a geoscientist, as a scientist in general. So here are all the scientist friends that I met and visited across the country and around the world in some cases. Things evolved from there. Seasons 2, 3, and 4 all include co-hosts. Many also include children, like some of the ones you just met, that help introduce the rocks and even have a conversation about some of the stories that we've learned about. Season 2, we were still stuck in the studio. But in seasons 3 and 4, we went on the roads. We traveled across the country and across the world to visit laboratories, and to visit exciting field sites like the Grand Canyon, the hills of Georgia, and the gorges there in Cornell University in that episode 79. We're over 177,000 views, 3,300 subscribers, which is more than I ever expected or intended to have. I joke with people sometimes about the view count, the subscriber count. A lot of the kids want to know, oh, how many subscribers do you have? And this isn't very impressive, but while I'm not trying to become famous by doing this, I will say those viewer numbers do matter to me, because that means that the message is getting out. So I do look at these, and it makes me happy to see these views going up, because it means that more kids, parents, teachers, and educators are finding this, and maybe, just maybe, getting more inspiration into their classrooms and into their own hearts and minds. So I do care about that. This is a nice slide because it shows all the faces. I'm in every episode, of course, but all the co-hosts and all the kids. There's Nashea, who you met. There's little Daniel from episode 57. And then who else did we meet? Nora in episode 55. There she is. And so many more, including some kids from the Boston Public Schools, which is where Mary teaches. So bringing in these diverse faces is a really important part of what we're trying to do. This is a fun video, something that happened after season 2, which also was very unexpected, but this is a lot of fun to talk about as well.
Hey, Every Rock Has a Story fans, I got some exciting news you are not gonna believe. Every Rock Has a Story Season 3 has just been nominated for a New England Regional Emmy Award. In Season 3, we traveled the country to film at some of America's greatest national parks, to visit some incredible laboratories, and to meet expert co-hosts who shared their own rock stories. Thanks to Boston College and to all of you for your support and for believing in our mission from the very start. We want to inspire the next generation of geoscientists through the wonders and the stories of the Earth, and to help all kids see themselves as scientists. Come see what everybody's talking about on Every Rock Has a Story.
So after season 1 and 2, we figured it out, and we've got a really nice product. And actually, I'm really proud to say that we've been nominated for a New England Regional Emmy 3 years in a row. Maybe we'll win one of these times. Again, that was never the goal, but I think it's important, at least for me, to see how far this project has evolved. And the quality of the later season episodes is quite a bit beyond what we saw just a minute ago. And I want to give you an example of that. So you saw episode 6. This is a beautiful crystal, which was the topic of the most recent episode, number 82. There are now 82 full-length episodes of Every Rock Has a Story. The more recent episodes are a little bit longer. Now we're going out to maybe 10 to 15 minutes of science content. So a little bit longer, maybe stretching, maybe more appropriate for that 4, 5, 6 age range. But again, all rated G, good for everybody. And again, to show you that evolution, I just want to spend a few minutes again to show you some excerpts from this episode number 82, Lithium Battery Rock. See where we've gotten to.
Are you out of batteries? Feeling a little tired? Like you could use a little more energy? Well, this dazzling mineral might have just what you're looking for. Lithium. Welcome to Every Rock Has a Story.
My name is Sam, and this is the rock for today. And I see it's purple, and it has these weird shapes. And I wonder, why does it like have these lines in the back? Hey, Ethan, can you tell me more about this rock?
Thanks, Sam, for introducing this rock to everybody today. Now, Sam noticed that beautiful pink-purple color. And these lines are striations right along the front. And on the back, she noticed these almost splintery shapes and fractures. Now, the flat sides and that pointy top are there because this is a real crystal. A crystal of a mineral called spodumene. Oh, and all these other rocks and minerals here today, these have something in common with our spodumene. They all contain critical minerals that we need for our modern society. Now, I have a geologist friend, and she is exploring for this critical battery rock all over the world. Let's go see where she is now and find out what she's doing. Hey, Catherine.
Hi, Ethan. Nice to see you. How are you?
I'm great. Thanks for being here. Everybody, I'm with Catherine Goodenough. Catherine is a geologist who works for the British Geological Survey. And Catherine, we were checking out this amazing crystal back in the studio. I bet you know what this is.
Ethan, that's beautiful. That's a beautiful gem quality spodumene.
I knew she'd know what this was.
So this is really important because this is the type of mineral that we would use as the ore for lithium. And of course, lithium is the absolutely critical ingredient of the batteries that we need for so many things in our modern world.
All right, Catherine. This is incredible. We just saw this drill rig in action, and this is the core coming out of the rig.
This is
lithium. This rock is lithium ore. And here is some of that drill core that came from underground as those geologists were exploring for more and more of that battery rock. Now, I'd like to bring back Sam to see what she thinks of the story. Hey, Sam. So now that Catherine has told the story, what do you think?
I think it was cool. What is lithium?
All right. So lithium is a very specific and very special ingredient that you can find in certain special rocks, like this crystal of spodumene. And lithium also has some very special electrical properties that can be used to help store energy. Season 4 was all about life's relationship with the Earth. We started with fossils, the ancient life of planet Earth, and the people who discovered them. We saw how today's scientists work together to unlock the stories of the past. We saw examples of how human life is impacting the planet today, and how scientists are working not only to diagnose those problems, but also to provide solutions for a more sustainable future. Yeah, life's relationship with the Earth sure has evolved. And you will play a role in how it continues to evolve in the future. I want to thank Catherine, Sam, and all the kids and co-hosts from season 4 for sharing their stories. I hope you've learned something about your own place on the earth and about your own relationship with the rocks and minerals all around us. Bye-bye.
All right, so that is what Every Rock Has a Story has evolved to. So I hope you'll take some time to take a look at more of the episodes, more of the stories, and share them with the kids in your life. I want to tell you more about how you can understand the resource itself and how you can navigate the YouTube channel to find the right kind of topics for your class, for your curriculum, for your needs. And after I go through a little bit of a tutorial of how the YouTube channel itself is structured, I want to turn things over to Jean and Mary, who can tell you about how they have brought Every Rock Has a Story into their learning environments. So the YouTube channel is easy to find. It's called Every Rock Has a Story. That's the actual link if you want to type it in. You can also scan either one of those QR codes if now or at any time. Or just searching a Google search for Every Rock Has a Story will take you right there. But you want to get to the channel itself. This is what the channel looks like when you get to the channel landing page. There's a little preview video up here on the top. And as I said, the real key part of the resource are the full-length videos themselves. There are 82 of them. Season 1 is the first 48 episodes, and those are the ones that are just me at home. Very, very low budget in those early COVID days. Season 2, we move into a proper studio with more proper production, but we're not leaving the studio. It's just myself and a co-host in the studio. Season 3 brings us out around the United States, and season 4 brought us to other co-hosts in the United States and abroad. And the way to find all those episodes is by clicking on that little videos link there if you want to get all the full-length videos in chronological order, or I've broken down each season in a different playlist, season 4, season 3, season 2, and just keep on scrolling down to find them that way. There are also shorts. And if you know anything about the world of YouTube, everybody's making shorts these days. They're limited to 60 seconds, landscape, sort of vertical format. I've got a whole bunch of shorts, but those are only they're only proportional. They're perfectly fun and all rated G, but that's not the meat of the content. I mention that because sometimes when one searches, the shorts come up because of the way the YouTube algorithm works. So they're great, but they're not the real meaty content. You want to get to those full-length videos. The About section, or what used to be called the About section, is right up here at the top. There's a little introductory section, and there are some links. I would especially encourage anybody who would want to take a deeper dive to go find those links. I wish there was a more direct way to point to them on the YouTube channel, but that's where they are. You can find educational resources, images of many of the rocks and the co-hosts, and a episode list on an online Google Sheet. This is what that episode list looks like. And I would, if nothing else, for anybody who really wants to dig in, this is where you need to get. It's a live Google Sheet. This just shows part of it, but you can see all 82 episodes are listed with their title, the year they came out, their duration, what's the sample featured, who was the co-host, who are the kids that are involved, where was the filming if it was done in a different location. And along the bottom here, you can see different topic categories. Maybe you want something that has to do with an igneous rock. Well, you can find all the episodes that speak to an igneous rock. Maybe you're talking about climate or energy or erosion and weathering. This is a great way to search episodes by their content. And at the other side of this giant spreadsheet, we see again the episode number and title, and then a short description of what the episode is about. So for a quick one-stop shop, in my opinion, this is a great place to go and just get a sense of what's available. It's going to fit my needs or my goals in my lesson today, this week, this month, this semester. And then a few other things. Each episode itself, when you click on it, there's a lot more information in the text, which is below the episode in YouTube. The trick is, if you click on an episode, you might get to something that looks like this. So this is Angela and I are meeting with Mary Anning's statue in episode 74. This bit right down here, you have to click more. And there's great content down there. And a lot of times people don't know you have to click on it to get more. But if you click on that, you'll find a lot more content. So we have some general information about the episode, descriptions of that entire season, links to the educational resources, links to the co-host, in this case to Mary Anning's website, and also NGSS themes. So all of the more recent episode, we indicate the NGSS themes that we think have something to do with that episode. Great information there. We also created some playlists on various popular topics like dinosaurs or volcanoes or climate. So that's another way that you can try to find the right kind of content for your needs. So with that, and having introduced the basics, I'd like to turn over the proceedings to my colleague, Mary O'Brien, who can tell you more about how she has brought this into her classroom. And Mary, I'll click the slides for you if you just tell me when to push along.
Terrific. Thank you. Welcome. Good evening, everyone. My name is Mary O'Brien. I'm a longtime second grade teacher who transitioned to STEAM 3 years ago. And I've been thoroughly enjoying it. So when this opportunity came up to participate in Every Rock Has a Story with Ethan and Boston College, my alma mater, I was excited. So currently I'm teaching grades 2 through 6, and I teach at the Dr. William Henderson Upper School, and it's in the Boston Public Schools located in Dorchester, Massachusetts. So I'm going to be talking a little bit how we've embedded literacy and expanded upon some of the thinking that we do with the videos. This first set of pictures is students doing a fossil dig. You can't really see up above. I was trying to keep the kids' faces out, but we had all the fossils up there identified where they would be found and whatnot, introduced them to some archaeological tools and let them dig. This Discovery Center that I try to change every month is a huge resource for the kids. So after we view episode 75, Fossil Fascination, the kids are really engaged and interested. And I do this with the students for several weeks. I see most classes twice a week, and we engage in activities. One of the first things we do is I let them actually have their own fossil dig with a Chips Ahoy or any chocolate chip cookie. And they use a toothpick to dig out the chips. And, I teach them the toothpick is similar to a chisel, and I let them excavate, and they get really excited. We also use some of the literature, like a Leakey book, Digging Up Dinosaurs, I believe it's called. I put a tag in it later on in the episode. But this was just my title page. This is full hands-on. There's 3 kids at those bins. It would be better with 2, but they want to have 90 at every given moment because they're fascinated by it. My tools aren't really authentic, but they work for this purpose. You can go to the next slide. Okay, reading. One of the things I really do like to do is to read aloud to the kids, and I find that they're more engaged, especially the older kids. They're more engaged in what we're doing with the lesson. So this particular book, I'm Trying to Love Rocks, is kind of a silly book, but Bethany Barton writes a series of these types of books that are great for my STEAM classroom. And in this particular book, it introduces the kids to the rich language that they need to know to support learning how rocks are classified and the formation process of the rock. So this is something I've always done with them since I taught second grade, because one of our big units in the focus on grade 2 curriculum is erosion and how wind and water affect the earth. So this has always been helpful. In this book, I would pull out excerpts from it at different times. And in this particular book, there is a little section on digging up fossils, and it gives the kids a little bit more background knowledge, which is beneficial for them as well. We can move ahead. This year, I did a little water study with them. Last year, we watched the episode 81 on clean water from clay. And it was late in the year, so I didn't really have enough time to really think about planning for the children. But I did have a copy of the book, The Water Princess. It's a fictional book, but it is inspired by the real childhood of model Georgie Badiel. And as an introduction to this unit, before I showed the video, I asked the children the question, what do you think makes water clean or dirty? And I actually went and collected local water from 3 sites. And then I had the children test it. The test strips that we did use were just like the type of testing strips that you might use in an aquarium, but that's what we had. And it was interesting. The students made observations. They looked at the chart. I had those charts on the back of the strips circulated at each station so that the children could really examine it, and they made their own conclusions about the pond's water quality. One student couldn't actually believe that I went around and spent my free time collecting water for them to study. They thought that was a little strange. I was like, well, that's what we do when we're in education. But it did help the students understand the importance of clean water around the world. We did filter it to see if we found any sediment. We really didn't. I mean, I did go to local places that were fairly clean. And then we followed up with episode 79 with gorge erosion. And I did this with 6th graders, and I did it with the 4th graders as well. And those are the 2 episodes. Here's another, these are some links if anybody's interested. Earlier this school year, I took a course with Worcester Polytech on their program, I Am STEM, STEM I Am. They had some great suggestions. One of the books that they suggested was Naya's Long Walk, A Step at a Time, written by Linda Sue Park. It's a great book. The children have really enjoyed that and looking at the activities, and that's I branched out a little bit from that and did some of the sample water testing lessons with them. The other book I mentioned earlier was The Water Princess, and that's illustrated by a local author, Peter Reynolds, author and illustrator. Then there's a great lesson plan in there from the education department at the Michael C. Carlos Museum that shows you some of the water vessels that are used throughout the world for collecting water. It's a really interesting tie-in to what was shared in the video. And I don't have that written down because I don't have the slide number, but was that 81?
81, yeah.
81. Okay. And then it, here's in the middle is a picture from The Water Princess, and it shows pots filling with the dusty earth-colored liquid. And that also goes back to what we learned in episode 81 as well. So it was really interesting. So it's kind of like making the pot to filling it and then getting some clean water. My little pictures I threw in. Another book that I've used a lot in 2nd grade and with 4th grade, because those are both standards on the erosion and standards in 2nd grade and 4th grade, is the Jason Chin's book. Now I'm watching episode 68 about the Grand Canyon with Becky Flowers. She goes into great detail talking about the layers and how old they are. And what's really fascinating is that the Jason Chin pictures match exactly what she shared. Almost like on target with every single thing from the top layer to the bottom layer. And then it shows the young boy looking at the fossils over here in the Calabar. Is that how Calabar? Limestone cliffs. And it shows him looking at those, which was pretty cool. So this book ties in really well with that. And then of course we do a lot of erosion projects around this theme as well. Like in 2nd grade, the kids were always asked to try to figure out a way to save the north side of Thompson Island, which is now Caitlin Stone Island. And with the 4th graders, we've looked at ways to protect Plum Island from their erosion and the different ways that works. So this is all like, it all ties in, and it's all really fascinating that we are able to do that with the children and keep them engaged. And now knowing more about these videos after the last several years, it's really helpful to have them to fall back on and for the kids to learn even more. I think I already talked a little bit about this, is what I do with the fossils with the kids. But one thing that I didn't have in my slides that came up when Ethan was sharing his video is after watching the episode on chalk with the children, we actually made our own chalk. And that got me really thinking about things too. And I don't think, and I know I've never thought about this in my whole life because I didn't think about it until I was making chalk with the kids, you know, in the last couple of weeks, is where does plaster of Paris come from? And why is it plaster of Paris? And why is it always a capital letter? So I said, it must have something to do with Paris. So I looked it up and I explained to the kids that it actually is from gypsum deposits that are found in the Paris Basin. That's originally where it came from. And that was the main ingredient in addition to water. And when I say a dribble of paint, because we learned the hard way to make the chalk colored. But it was really fun. And we had a lot of fun doing that and making sidewalk chalk as a result of watching the video on the chalk.
I love it.
Yeah, so it was kind of cool. And something that happened today, and these are books that I do use, especially with the erosion unit in grade 2. And I don't always use the entire text, but I use excerpts. And with the Grand Canyon, every kid in 2nd grade in Boston Public Schools knows what Horseshoe Bend is, because that's like the huge like introduction to the units. They learn a lot, and they learn a lot about different landforms and rock formations around the world, which is pretty cool. And then the next page is just a couple of Ricky the Rock That Couldn't Roll. That's a silly story. It's kind of like a self-esteem story for kids, but it shows how a group of rocks work together. And it ties into another episode, which was, and I'm probably not going to get this episode correct, the episode where the rock that was found didn't belong where it was found, and it had come through the glacier.
52. Yes.
Yes. In this episode, in this book, Ricky the Rock That Couldn't Roll, there's a rock that doesn't belong in that rock community, and they figure out a way to make him fit in. So it's kind of a light book that's fun. But what I started to say earlier was this 4th graders are going to the Olmsted homestead this week. And I read them the book today, A Green Place to Be, The Creation of Central Park, which tells the story of how Frederick Law Olmsted became a landscape architect, and how he and another gentleman worked together to collaborate to build Central Park. And I've read this book many, many times, but one thing that stood out today, again, from doing this work with Every Rock Has a Story, is how they had to blow up a lot of Central Park, and the rocks, they had so many rocks from that excavation and getting the land ready, and they repurposed all those rocks within Central Park. And then which was kind of cool. So the kids were pretty amazed about that. So they left STEAM today with a lot of more information about Frederick Olmsted. And so I hope they have really good questions when they go there on Friday to share with the people that work there and run his legacy. But thank you.
That's
Happy to answer any questions.
Mary, thanks so much. I want to flip it to Jean. And before I do, I just have to say, for me, I'm so inspired hearing ways in which people like you, Mary, are bringing in so much more into the conversation. So something that we'll close with later on. Every Rock Has a Story should only be one small part of the connections that we're able to make in a classroom, and seeing all the literacy, the activities. That's what this is all about. So Mary, thank you so much for sharing all that. And I will now flip it over to Jean Overy-Rothman to tell us about maybe a little bit the larger scale of Every Rock Has a Story.
Sure. Hi, everybody. Thank you for being here. So I worked for 10 years as an elementary classroom teacher, and then I worked for another 10 years as a curriculum coordinator for math and for science. And I was pre-K through 6 at that point, but I also collaborated a lot with my junior high and high school colleagues. And that was in that role that I met Ethan and became involved in this project. And then more recently, I've been working at the adult ed level, working with adults who are pursuing their high school equivalency. So I've kind of got the full range here. And so, I wanted to just share some ways that the bigger picture of Every Rock Has a Story. So I'm trying to tie it into the NGSS, the 3 strands of NGSS, thinking, and Every Rock Has a Story can hit all of these strands. So on the science core ideas, as people mentioned, there's certainly the earth materials and systems with erosion and weathering, the role of water and ice. But there's also the history of planet Earth. There's things about the universe and plate tectonics, volcanoes, earthquakes, lots of fossils, and natural resources, energy, big theme that you can pick up on around energy sources, Earth and human activity and climate change, especially, I think it's season 3 and 4 that are kind of picking up those themes around Earth and human activity. But if you're like, wait, I don't teach 2nd grade, I don't teach 4th grade, these aren't my standards, there's a lot more to it as well. There's episodes that touch on biological evolution through the fossils piece. There's a lot of structure and properties of matter if you're looking at a chemistry, physics kind of things. And again, like I mentioned, energy is a big theme as well. So there's a lot of broad range. It's not just rocks and minerals. You want to go to the next slide, Ethan? Thank you. And then the cross-cutting concepts. Again, I just said energy, but energy and matter, cause and effect, stability and change, interdependence of science, engineering, technology, and the influence of engineering, tech, and science on society and the natural world. And it's the stories that drive these cross-cutting concepts. From the stories, it can be an episode about chalk. We've been talking about that one a lot, but it's talking about changes. It's talking about there's some technology in there too. And we're thinking about how chalk is used by humans, but also the history of it and the climate change piece. So it's that idea of cross-cutting concepts. The videos really do a great job of kind of cutting across the boundaries of the different science fields and different ideas. So, and we'll go to the next one. Thank you. And the science practices. This, I think, is one of the hidden gems of Every Rock Has a Story. Teachers are like, yeah, the science practices, yeah. But it gives you a way to see actual practicing scientists, to have kids see what these scientists are doing, especially in the last 3 seasons. But you see them asking questions, using models. You actually, sometimes it's in the lab, sometimes it's in the field, but you actually see scientists at work. And sometimes on the math side, they're interpreting data or they're taking a look at their data, sharing with the kids in kid-friendly language too. That's another thing. They're not talking to kids at the PhD level. They're talking on a kid user-friendly level that really makes it feel accessible. And about communicating information. Everything they're doing is they're showing how they are obtaining and evaluating information, and they're communicating it by being in these videos. They're communicating about their science. And I'll pick up on that in just a second. But really, all 3 strands of the NGSS are there, and we've done our best to kind of link it into the individual episodes at the bottom if you're looking for standards. But it's a high quality thing. I know when I was a curriculum coordinator, I was telling teachers, don't just Google something that you need to teach tomorrow. But this is a trusted resource. It's high quality and it's really done thoughtfully. And it's great science and a great resource to know about. We'll go to the next slide. Thank you. So that's if you're looking for your standards and stuff, it's all in there. But the beauty of these videos can be used in lots of other ways as well, beyond the traditional classroom. If you have a student or a child of your own who's just needing a little bit more, that idea of student enrichment for the kid who just needs a little more, this is a great resource. Here, check out these videos. Tell me what you learned. Create your own, science journal. Show me what you did. I know from my own experience in those very first episodes, Ethan sent them to me and I played them for my then 6-year-old and 3-year-old, and they got out their dinosaurs. They watched the video on dinosaurs. Next thing I knew, they've got the dinosaurs out, and I said, what are you doing? They said, we're being scientists. And that was when I sent Ethan an email saying, "Yep, this is good. Keep going." So especially, for kids at home, like, it's quality YouTube. There's a lot out there that's not, but I always tell my kids, I'm like, go watch some of the rock videos. They're older now, but they still, when I push them to watch something more high quality, they learn a lot from the videos when they watch them. Another thing is out of school learning. So if you are involved with after school programs or summer camps or libraries, museums, these can be a great resource for those kinds of things, especially, summer camps and after school programs are kind of coming up with a theme. Well, maybe geoscience is your theme, or earth science, or just having fun with the earth. And again, the videos are not a replacement for hands-on activities. None of us want that, but they're a great supplement to it. See people out in the world doing these things in Europe, like learning those things. So it can be really beneficial for out of school learning things too. So it's not just classroom learning. And then some other things that the videos can be used for, they're not the original intent of the videos, but I think they have a lot of power. Teachers, you can build some background knowledge, like, oh, I need to learn more about something that you're teaching. You can learn the story, and maybe the video doesn't work for you for whatever reason, but you learn the story and share it with your students. And so it's kind of building that teacher background knowledge, building your own confidence in what you're teaching, and kind of having those stories in your back pocket, because that's really what it's about, is the stories. And we know from research that all people learn through stories, and that's what we remember and we hold on to. So another tool, I know some of my colleagues who worked at the high school level, and I could imagine college as well. Some high school AP environmental science teachers would always do a kind of end of the year project around science communication, usually encouraging their own AP students to create some kind of project to convey something that they learned to elementary students. And I think these videos can be a great resource as an example of science communication. How do you take complicated scientific concepts and make it accessible and approachable for anybody? And I think college courses around science communication could also kind of use it as the same way. And maybe high school or college students make their own rock video or another video on a different science topic. But that skill of taking science concept and bringing it down to a level that's accessible, but still fascinating, and preserving that curiosity is a real highlight. And so I wanted to point that out. And then from my most recent experience working in adult education, I did use pieces of a few episodes with my adult learners. We specifically used the episode 82 about the lithium. And I asked them, I told them, I was like, these are made for kids, but I want you to see it. And we were learning about energy. And I said, I just want you to take a look at this and tell me what you think. And they said, that was fascinating. I didn't know that that's what lithium looked like. I didn't know that's where lithium came from. Watching them drill, that was so neat. So kind of exposing everybody to some of these really neat, fascinating things that we're not exposed to regularly. So just wanted to share all of these other ways that the videos can be used outside of their original intent that have so much power. And again, it's about bringing these messages and these ideas to as many people as possible. So.
Thank you so much. And again, I just feel so blessed to have worked with such incredible colleagues like Jean and like Mary, and see how they're taking this resource that we've created and are doing so much more with it and bringing into everything else that they're doing in creative ways. This is our last slide. So just to sum up on some of what we've said, I think Jean and Mary and I have all expressed this. Every Rock Has a Story is a great part of, or a supplement to, or an enhancement for everything else that you're doing. What's nice about it is it can enhance a lesson by bringing in those different faces, increase that sense of belonging. You can bring a real scientist to speak to your children and show them what they're doing, those science practices in action, to really inspire kids, to get them excited, interested, to find value in these really important geoscience concepts. And as I think all of us have showed, find ways to show students how to make connections to other parts of the sciences, to society, even to the humanities in some cases. So we encourage you to pick a rock, pick a scientist, and take a look at some of these videos and see what you can do to spark some activities or discussions. And I think where I'll leave is what something that Jean just said. These aren't my stories. These are the stories of the earth. These stories are for everyone. And so my hope is that they can be told and shared to inspire more kids, more parents, more teachers, all of us. So whether you show a video or learn the story and tell them in your own way, that's what this is all about. So thanks for spending the time. We've got about 10 minutes left for questions. And so I'll flip it back to Missy to moderate some questions and answers.
That was absolutely amazing. We can't thank you, Ethan, Mary, and Jean for everything that you shared today. You're all an inspiration for us. There is one question in the chat box to get us started. It says this from Rihanna. It says this is great resources all around here. I work in a Spanish immersion school. Is anyone aware of these materials being available in Spanish?
That's a great question. And who asked that? It was
Rihanna?
It was me, Rihanna. Yep.
Okay, great. So I'll tell you two things. So as you probably know, on YouTube, you can use a Spanish captioning. It does exist. It actually can caption almost any language. It's not perfect. And obviously you're going to lose a lot, in the translation going to Spanish. So that does exist. Outside of that, I haven't created any Spanish language versions. That would be difficult for me to do personally for a host of reasons. But one thing I will tell you, I actually was just in touch with a colleague of mine in Spain, someone with whom I've done research, and he's invited me to write an article about Every Rock Has a Story that will be published in a Spanish educational journal. So the plan is that I will contribute an article in English, and they will translate it properly into Spanish. So that is a resource that I'm going to hope will come out something in like the next 12 months. But I will just say, I think your point's a really good one, and reaching out to different language communities is something that I would love to do. It's just not a skill set that I have personally at this time, but I really appreciate that question.
Great, thank you. Another question is, how do you identify the level of content for your stories?
The level of the content. So maybe I'll start with that. And I'm actually curious what Jean and Mary might add to that as well. I know you guys haven't been part of making the episodes, but you've seen how they work in the classroom. The episode 1 that I start with, I really was sort of pulling out my own favorite stories. And those are stories that have become my favorites because I've shared them with kindergartners and second graders and fourth graders and sixth graders in person. So I knew that they worked. And so I think those would be examples of stories that I've told many times in the classroom that do connect with students. And they connect because there's an interesting hook. There's something to see. There's something to talk about. That rock, we always start with the basics. What do you see? What do you notice? What do you wonder about this object? And then I can spin that yarn that goes into topics that most kids understand. For the more recent seasons, it was a blend of finding a topic that I thought would be interesting and relevant, and at a level that a student could grasp and fit with a co-host who was able to find and recruit to tell that story. So it was a little bit of a dance of, well, I'd like to get that person. What would you like to talk about? So those were more sort of finding the fit between a viable topic and a co-host themselves. And it's wonderful hearing from the co-hosts. Of course, they're all different. That's the whole point. Their storytelling approach is very different. The kind of things that they emphasize is different. And I think it's just wonderful to see all those different co-hosts telling their own stories, their own ways. I would say just a couple more things. With that said, I think season 2 probably ended up being maybe shooting at the highest level of an audience. That wasn't necessarily in the intention, but I'd say that maybe season 2 is maybe good for like that 5 to 8 range in terms of content and understanding. And then seasons 3 and 4, we really try to come back and focus on that 3, 4, 5 grade level, which is I know where Mary has been using them recently in the Boston Public Schools. In our understanding from some surveys we've run with the students is that in that 3 to 5 level, they're doing very well in comprehending and understanding the content. That's their own student feedback. And I'm curious, perhaps Jean or Mary, anything else you'd add to not just necessarily the content choice, but what's working with the different age categories?
Yeah, I think a piece of it is kind of being flexible and thinking about it. Like if you're teaching 4th grade erosion, then you've got a slam dunk. You can find that episode on erosion and you're good to go. If you're not teaching 4th grade or 2nd grade erosion, but you want to use the videos, then it's more of finding your content using that searchable list and seeing and watch the video yourself. They're short, but watch it and make sure it is kind of fitting what you want. And you can always use digital tools like Edpuzzle or Google Slides, and there's other ones out there to cut out pieces. If it's too long for you, you can shorten it. I did that with my adult learners. So kind of using it in a way that makes sense for you. And then the other piece too is with the co-host, as Ethan was talking about, they tell their stories differently. Ethan always does a wrap up at the end where he drives home that story and makes the connections for the kids. And I've told many people, Ethan is the only person I know who can engage a kindergartner through a graduate student and fully engage them and talk to them on their level. But he does a great wrap up at the end of each video to kind of clarify those science concepts and the story to kind of bring it all home at the end.
I don't really have any set curriculum for STEAM. So because I was in the classroom for so long teaching grade level content and I knew a lot about what the other grades had to do, I can kind of work with what I know is going on in each classroom, and I confer with the teachers a lot too. So I can adapt things, and if the students have a specific interest in one particular thing, like I mentioned before we started, that one 4th grade class was kind of fascinated with learning more about gold and fool's gold and the gold rush. So we did that. And then I was able to go into Pebble Go. I don't know if anybody uses Pebble Go, but Pebble Go and get a story about the gold rush that kind of expanded the kids' thinking so they could learn a little bit more about it. So I have that flexibility and I can change it around for the different grades. So that part is interesting too, because some classrooms have a focus on something they're interested in, and even if it's the same grade level, another classroom may not be. So I can tweak it a little bit just to make it so that everybody's getting something that they want.
I got you. I have a question for you. You're an unbelievable master teacher. It's just very easy to tell that both of you and Jean are, just from what you've been sharing. Have you thought of thinking about the young educator, somebody that's coming new into the business? Have you thought about bundles of, okay, we have this video and marrying it with literacy and this particular book and this particular activity? Because it just seems like you've got this like touch that can pull this together, this together, this together. But somebody that's new in the business of teaching might not have that skill. So what are your suggestions for somebody like that?
Well, I'm the first one at school every day, and my door is always open. So I am helping a lot of young teachers with different things. I will say one thing I did do during the height of the pandemic in the following hybrid year is I made a Padlet for 2nd grade for like every single week. And every single 2nd grade teacher in my school uses it. And I know that other 2nd grade teachers in other schools use it because I've been asked to like support them in that too. So I made a lot of presentations. So yeah, I do help them, and I do share and collaborate with as many teachers as I can to help, because it's a different world out there now. The training isn't the same as it used to be for a lot of different reasons. No one's at fault or anything, but I do try to support and help them figure everything out.
You're a wonder to the field of education, so I appreciate all you do.
Agreed.
Diana has a question. Diana, you put up something in the chat?
Yeah, I have a question. We teach geoscience to grade 9, 10-year-old, not grades 9 and 10 here in Hong Kong. And we use parts of the NS and NGSS in grades 3, 4, and 5, and we do it bilingually, but we don't get through the entire curriculum. But in our grade 9, 10 geoscience course, we're using a curriculum that was actually written by Dave Christian on the big history. Are you familiar with that, Ethan? It's really from the Big Bang Theory to the modern world. It includes human impact. And I'm seeing, I think it would be, I'm just curious if you've evaluated that, if you've looked at that in your career. And I think you could go up and down between probably grade 3 to grade 10, 11 with the Big History Project. But we're just really here in this part of the world, in Asia. See, Dave Christian was originally Australian, and we're just seeing some momentum here in Hong Kong and in the region, believe it or not, Oklahoma, around Big History Project. And I was wondering if you're familiar with it or what your thoughts on it might be.
Yeah, so I have heard of this. I've never interrogated it or used it myself. So I don't have familiarity with it, but it is something I've heard of. And I think I love the idea of stitching things together across space, spatial scales, time scales. I think is really valuable. I will say another perhaps broadly similar structure that I use in my undergraduate classes is a framing of a book by Wally Broker called Building a Habitable Planet. And so the structure of that one, which is again definitely for an older audience, but it's that structure of, all right, so what makes the Earth, and how has it come to be the way that it is? I think in a broadly similar way, I think that succeeds in tying many, many different themes together in a way that makes some sense. But I appreciate your suggestion. So this is something, again, I've never delved into it myself, but I'll take a look for my own teaching interests. And I'll just say one other thing that I think it was Jean. Yeah, it certainly was Jean who already mentioned. As I think you've also gathered, Diana, while this particular resource, Every Rock Has a Story, was decidedly made for elementary students, I use it with my undergraduates. Jean's brought it to adult learners. And so what I found is if I disarm my audience by explaining very clearly, these videos were made for children. I didn't make them for undergraduates. They were made for children. Then with that sense, I found that they can actually learn a little bit, get a few laughs, and then it can lead to a conversation and some of that broadening. So, but I will take a look at the biggest.
Yeah, we've used. I'm not the actual teacher in the classroom for this geoscience course here in Hong Kong, so I'm not sure which of the Every Rock episodes the classroom teachers use, Rachel Oser, but I do know that she uses it as a starter, to kind of get kids thinking when they're coming into the classroom. So doing slightly different things with it, with these grade 9, 10s in the geoscience course. And we ran up against, when we wanted to offer this course using the Big History curriculum, we ran up against the history department or the history teachers at the school saying, yeah, but we teach history. So then that's when we kind of said, okay, we'll rename it. We're going to call it a geoscience course. And it goes literally from Big Bang all the way to, the Industrial Revolution and human impact on planet Earth. So there's, what I see with this is, I would see that there's a lot of connections that could be used for that. And like Jean said, you can extend it beyond primary school with a little bit of thought behind it as to where you make the next steps. But we've been we're working hard on the we're working hard with the big history project right now.
Okay, all right. At that point, I think we're at a juncture where we're a little 2 minutes past. So we're just going to wrap up everything today. And first off, we don't have the time for a lone space for reflection. So I'm going to ask you to take away these little topics here. What are your takeaways from today's webinar, and how might you use these to share? So I'm going to ask, when you leave the webinar today, to take 5 minutes and reflect on your experience today and think about what we've learned. And then we've already done questions, so we're going to skip past that. And just a quick thank you to our AGU team for hosting this, because without them, we would not have been able to run the technology and all that. So big thanks to AGU. And reminder, if you are an AGU member, thank you very much. If you are not a member of the education section, consider joining us. Diana and I would love to have you in the K-12 working group. I'd love to have you sharing in ideas and everything else with us at the K-12 level within the education working group. So with that, I'm going to thank our presenters for this evening. We can't thank you enough for all of you that you've shared. And we'll shut the webinar down now. So unless there's any final questions or comments in the chat, we'll stay on for just a couple quick seconds. But at this point, we thank you very much for joining us.
Thank you, everyone.
Okay. All right. Have a good night, everyone. Thank you.